Hello, and welcome to a Tonicity session.
Tonicity?
Wow,
Tonicity!
We love
Yay!
Tonicity. Tonicity's #1 fan. First, let us start off with the 3 types: hypertonic, isotonic, and hypotonic. In hypertonic solutions, the solute concentration on the outside of the cell would be greater than that of the inside, so the water concentration would be lower on the outside of the cell. So in a situation where 10% of salt solution was in the cell and 15% were in the environment, the water molecules would go outside where the lower water concentration is. And thus, in hypertonic solutions, water moves out of the cell. This innocent cell looks unsuspicious. But whoa, it's shrinking. That's because hypertonicity causes cells to shrink. Now take a look at this small, little, dandy plant cell. It looks happy, right? But no, it's actually really sad and miserable because it's losing water and its plant is dying. This is because in a hypertonic solution, plant cells lose water and start to wilt. Now, the process of water moving out of cells is called plasmolysis. I'm just kidding, it's plasmolysis, I think. That's a big boy word. Now for isotonic solutions, the solute concentration and water concentration are the same for both outside and inside of the cell. For isotonic solutions, the solute concentration and water concentration would be equivalent inside the cell and outside of the cell. This means that there would be no net water flow. Physics flashbacks. See, the question now is, why am I drawing a puppy? Well, there are many reasons. The puppy is relevant. It's cute. Also, it is an animal, and animal cells need isotonic solutions to maintain homeostasis. Also, in isotonic solutions, the water does not stop moving. It still flows, it just flows in and out at the same rate. Well, in the end, that would mean that equal amounts of water are in and out of the cell. For hypotonic solutions, the solute concentration outside would be less than the solute concentration inside of the cell, so the water concentration would be greater outside of the cell. That means that the water molecules would want to go inside the cell where there's a lower water concentration. And so, if there were to be 6% of salt solution inside the cell and 3% in the environment, the water molecules would go towards the inside of the cell. So therefore, in hypotonic solutions, water moves into the cell. Now this cell also looks innocent and unsuspicious, but look, it's growing, and now it blew up. I got trust issues with these cells. Anyways, the reason for this is because animal cells increase in size and burst in these solutions. Ooh, fireworks. 4th of July barbecue in my backyard. Also, the bursting of cells is cytolysis. Now, we're just painting a cute little sunflower like Bob Ross. But why is this relevant? Because plant cells need hypotonic solutions to maintain homeostasis. And so now, here we are illustrating 2 plant cells. On the left, there's a happy little plant cell who's pushing the cell membrane against the plant cell wall. And the one on the right is just not achieving that, you know? And this is due to something called Turgor pressure, which I'm assuming is invented by Mr. Turgor. And this is the reason why the cell's membrane is pushing against the plant cell wall. In conclusion, I've concluded a conclusion in which I conclude that I thank you for watching, because this was a pretty peaceful session, and science can be scary, like this hamster represents, but I think this all helps us understand tonicity. So all I can say is thank you and peace out.